Hello all. Today we are going to see some problem of second chapter elementary functions. So let's see problem number 7. Find all complex solution to each of the following equations. First one, e raised to w equal to I. We know that for the equation e raised to w equal to z, the set of solution is given by w equal to ln z, where ln z is found from the formula ln z equal to log e mod z plus I argument z. So here the first question is e raised to w equal to I, where z is equal to I. So we will get mod z as 1 and argument z equal to pi by 2 plus 2n pi. So substituting this all in the equation w is equal to ln z, we get w is equal to ln I, which would be equal to log e1 plus I into pi by 2 plus 2n pi, which on simplifying we will get 4n plus 1 into pi whole divided by 2 into I. And second question is e raised to w equal to 1 plus I. Here z is equal to 1 plus I, so we'll get mod z equal to root 2 and argument z as pi by 4 plus 2n pi. Again, as we have done in the first question, we'll substitute these equations, this values into w equal to ln z. So we will get w is equal to ln of 1 plus I, which is equal to log e root 2 plus I into pi by 4 plus 2n pi, which on simplifying we will get half log e2 plus I into 8n plus 1 into pi whole divided by 2 for all n equal to 0, plus or minus 1, plus or minus 2, etc. And similarly we can do the third problem also, which is e raised to w equal to minus 2. Here z is equal to minus 2, so mod z would be equal to 2 and argument is pi plus 2n pi, which would be equal to w equal to ln into minus 2, which is equal to log e2 plus I into pi plus 2n pi, which would be equal to log e2 plus 2n plus 1 pi I. So that's problem number 7. Now we'll move on to problem number 8, which is find the derivatives of the following function in an appropriate domain. First one is z ln z. Here z is an entire function and ln z is differentiable on the domain defined by mod z greater than 0, where minus pi less than argument z less than pi. Hence, by the rule of differentiation, it follows that z ln z is differentiable on the domain defined by mod z greater than 0, where minus pi less than argument z less than pi. Using product rule, the derivative of z ln z in the domain would be given as d by dz into z ln z, which would be equal to z into d by dz ln z plus d by dz of z ln z, which would be equal to 1 plus ln z. And second question is ln of z plus 1. Here the function ln z plus 1 is a composition of the function ln z and z plus 1. The function z plus 1 is an entire function and ln z is differentiable on the domain defined by mod z greater than 0, where minus pi less than argument z less than pi. Hence, from the chain rule, it follows that ln of z plus 1 is differentiable at all points w equal to z plus 1, such that mod w would be greater than 0, where minus pi less than argument w less than pi. In other words, this function is differentiable at the point w, where w does not lie on the non-positive real axis. To determine the corresponding values of z, for which ln z plus 1 is not differentiable, we first solve for z in terms of w to obtain z is equal to w minus 1. The equation Z is equal to W minus 1 defines a linear mapping on the W plane onto the Z plane given by translation by minus 1. Under this mapping, the non-positive real axis is mapped onto the ray emanating from Z is equal to minus 1 and containing the point Z is equal to minus 2. This implies that ln of Z plus 1 is differentiable at all points Z that are not on the ray emanating from Z is equal to minus 1 and containing the point Z is equal to minus 2. For such points, using chain rule, we get d by dz ln of Z plus 1, which would be equal to 1 by Z plus 1 into d by dz of Z plus 1, which would be equal to, on simplifying, which would be equal to 1 by Z plus 1. So that's the 8th question. Now let's move on to the 9th question. Find the image of annulus 2 less than or equal to mod Z less than or equal to 4 under the algorithm mapping W is equal to ln Z. So here we know that W is equal to ln Z maps the circular arc mod Z equal to R, theta naught less than argument Z less than or equal to theta 1 onto the vertical line segment U equal to log ER, where theta naught less than or equal to W less than or equal to theta 1. Hence the boundary circle mod Z equal to 2, where minus pi less than argument Z less than or equal to pi, and mod Z is equal to 4, where minus pi less than argument Z less than or equal to pi of the given annulus map onto the vertical line segment U equal to log E2, where minus pi less than V less than or equal to pi, and U equal to log E4, where minus pi less than V less than or equal to pi. In a similar manner, in each circle mod Z equal to R, where minus pi less than argument Z less than pi, where 2 less than or equal to R less than or equal to 4 maps onto a vertical line segment U log ER, where minus pi less than V less than or equal to pi. Since real algorithmic function is on increasing on its domain, it follows that U equal to log E takes on all the values in the vertical interval log E2 less than or equal to U less than or equal to log E4, where 2 less than or equal to R less than or equal to 4. Therefore, the image of this annulus 2 less than or equal to mod Z less than or equal to 4 under the logarithm mapping W equal to ln Z is in the rectangular region log E2 less than or equal to U less than or equal to log E4, where minus pi less than V less than or equal to pi. The annulus and its image are given below. Thank you.